Hi student, how are you all? Today we are going to discuss a very practical example from our daily life. Yes, say if you take a container, okay, or you are taking a vessel, simple vessel. Now, if there is no liquid in that vessel, then you can see the actual depth of that vessel, okay? But if you fill that vessel with a liquid, say a transparent liquid we are taking, say water. If you fill that vessel with water, then if you see the depth of the vessel, you will notice that the depth of the vessel is reduced now. Yes, it's reduced. Practically it is not reduced, but when you see it, it looks like that the depth of the vessel is reduced. You understood what I said? If I draw the diagram of it, see. Say, this is the vessel. Okay. So when you are seeing the vessel, you are saying this is the actual depth. Okay. But when you fill the vessel with liquid, say water, I fill the vessel with water, then you will observe that the actual depth of this vessel is reduced now. Okay, you will see that the base of this vessel is here now. Okay, without liquid, this is the base of the vessel. But when it is filled with liquid, you will see that the base of the vessel is raised up. I mean here you are saying. Okay. This is the fact of refraction. Yes, refraction. Now if you do not know, or if you do not have the concept of refraction and refractive index, then you should see the video. The link of that video is there in the description box, where we have discussed about refractive index and refraction. You must watch that video first. Okay. So if you know the refractive index and refraction, then let's go ahead with this example where we discuss that without liquid you can see the base, means actual depth of the vessel. But when the vessel is filled with water, okay, not only water, any liquid, then you will observe that the base of the vessel is raised up. Okay. Now I will tell you some relation. Okay, some relation based on this actual depth and all. What is that? Let's see. Now for this vessel, if I ask you what is the actual depth, then you will say that this is the actual depth. Okay, the actual depth of the vessel. This is the actual depth, or you can write AD, actual depth. Okay, or we call it real depth, actual depth or real depth. Okay, but when the vessel is filled up with water, then you see that the base is raised up. Means now this is your apparent depth. Okay, this is the real depth, I mean actual depth, and AD is the apparent depth. Means it's apparent like, it appears like the base is raised up. So this is my apparent depth. Okay, now if you divide this real depth by this apparent depth, okay, this real depth you divide by apparent depth, then you get the refractive index. Refractive index of which liquid you are using here? Say we are using a particular liquid, say L. Okay, L is that particular liquid. L with respect to A. A means air. Yes, air. Okay. So this is mu, refractive index, as we discussed in that video. I told you the link of that video is there in the description box. Yes, according to that video, refractive index, this is L. L means yes, that liquid, refractive index of that liquid, and this is air, okay, which is equal to real depth by apparent depth. Fine. Now say we are doing an experiment, okay. According to that experiment, say I am taking a vessel whose depth is 60 centimeter, okay, whose depth is 60 centimeter. Now 60 centimeter is the real depth. Fine. Now we are filling this with water. With water this is filled up. Now if you see it, if you see the depth, then you will find that the base is here now. Okay, the base of the vessel, you will see that the base of the vessel is raised up. Okay, so what is this depth now? This is called, yes, apparent depth, AD. Say apparent depth is 45 centimeter. Okay, apparent depth is 45 centimeter. Now we have filled this with water. Okay, then we can say that refractive index of water with respect to air equal to real depth, that is 60 centimeter by 45 centimeter. Any doubt? I'm sure you do not have any doubt, because it's very simple relation. The relation is refractive index of the liquid by which you are filling it up. Here I have filled up with water, so refractive index of water with respect to air, and which is equal to 60 centimeter by 45 centimeter, that is real depth by apparent depth. Got it? Now let us find it. So refractive index WA equal to centimeter by 15, 4 ja by 15, 3 ja. So 4 by 3. This is the answer. So refractive index of water with respect to air is 4 by 3. Okay, this is an important numerical for your exam. Okay, one more numerical is important for your exam, that is the example of a glass slab. Okay, example of a glass slab. Say for that I am taking this book. Okay, I am taking this book and I am making here a black dot. Okay, can you see this black dot here? Yes, this black dot I am taking. Okay, after that I am taking a glass slab. Okay, rectangular glass slab. Just keep the glass slab on this black dot. Okay, keep it on. Now you see, directly you see, okay, through the glass slab, see this dot. You will observe that this dot is raised up. Understood? Let us draw it. Say this is the paper, this is the white paper. Now on that white paper I made a black dot. Okay, and this is the glass slab. Understood? This is the glass slab. Fine. Now I can say that if I see from here, I will see that the dot is here now. Yes, it's appearing like the dot is raised up. Okay, so I can say that this is my real depth. Real depth. Okay, this is my real depth, and this is my apparent depth. Apparent depth. Understood? Real depth and apparent depth. So this is an experiment we are doing, and say we got real depth is say 21 centimeter. Means this glass slab, the height of this glass slab is 21 centimeter. That means real depth is 21 centimeter, and this is apparent depth. Apparent depth is say 14 centimeter. Apparent depth is 14 centimeter. Got it? So I can use this equation now. What is that equation? Refractive index of glass. Since we are using glass here, I told you glass slab. So glass, refractive index of glass with respect to air, because air is there. Okay, refractiveness of glass with respect to air equal to real depth by apparent depth. What is real depth? Real depth is 21 centimeter by apparent depth is 14 centimeter. Centimeter cancel. By 7 you cancel it. 7 3s 7 2s. So equal to 3 by 2. 3 by 2 is the refractive index of glass with respect to air. So easily we can calculate it. So these two numericals are important for your exam. Okay, you must prepare this numericals. So I hope you understood the concept that how real depth, apparent depth are related to the refractive index. And one more thing comes in the exam, that is called shift. Yes. What is the shift here? Shift means real depth minus apparent depth. I mean this is called shift. This one. How much the base is raised up. Understood? How much this dot has raised up. That is called shift. So this is shift here. And shift means real depth minus apparent depth. Yes, from the figure, this is real depth and this much is apparent depth. So shift is real depth minus apparent depth. So in this first case, what is the shift? 60 minus 45, that is 15 centimeter. So shift equal to 15 centimeter. And what is the shift here? 21 minus 14, that is 7 centimeter. Shift is 7 centimeters. Okay, so I hope you understood the relation between real depth, apparent depth and refractive index. And these numericals also are very important. Okay, see you in the next topic of refractive index in our next class. Okay, bye all.